The day fire fell from heaven, the 1888 Sulaymaniyah meteorite. The sun had barely crested the Zagros Mountains when Ahmad al-Saadi stepped into his courtyard that August morning in 1888. In the Kurdish city of Sulaymaniyah, nestled in what is now northern Iraq, the day began like any other in the waning years of Ottoman rule. Merchants prepared their stalls in the bazaar. The call to prayer echoed across clay rooftops. No one suspected they were about to witness something that wouldn't be fully understood for more than a century. What happened next would make history in the most literal sense possible, becoming the only scientifically documented case of a human death caused by a meteorite strike in recorded history. When the sky split open, witnesses described it as a sound that preceded comprehension. First came a shriek, high and terrible, like metal tearing through fabric. Then a thunderclap so violent it shattered windows 3 streets away. In the chaos that followed, as dust billowed and screams filled the air, few people immediately understood what they had seen. A streak of fire, a blinding flash, and then silence broken only by anguished cries. Ahmad al-Saadi lay dead in his courtyard, struck down by a fragment of rock that had traveled millions of miles through the cold vacuum of space. Beside him, his neighbor writhed in agony, his spine shattered by debris from the impact. The paralysis would be permanent. For decades, this incident existed only in local memory and fragmentary accounts. But in 2020, researchers pouring through Ottoman administrative records and Turkish archives made an extraordinary discovery. Buried in the bureaucratic correspondence of the empire were detailed reports of the incident, official documentation that would finally give Ahmad al-Saadi's death the recognition it deserved in the annals of science. The paper trail. Across centuries, the Ottoman Empire was nothing if not meticulous in its record-keeping. Provincial governors filed regular reports to Constantinople, documenting everything from tax revenues to unusual occurrences. It was in these administrative archives that researcher Ozan Unsalan, working with a team from Ege University in Turkey, uncovered 3 separate documents referencing the 1888 event. The reports described a fireball descending from the sky, followed by an explosion and the deaths and injuries that resulted. The language was precise, almost clinical, typical of Ottoman bureaucratic style. But reading between the lines of formal Turkish script, one could sense the governor's own bewilderment at having to report something so unprecedented. What makes these records extraordinary isn't just their existence, but their specificity. The documents noted the exact location, Sulaymaniyah, then part of the Mosul Vilayet. They recorded the date with precision. They listed the casualties by name, and crucially, they described the physical evidence. Strange rocks, still warm, scattered around the impact site. The governor's report made its way through the Ottoman postal system to the imperial capital, where it was filed, catalogued, and forgotten. It would remain buried for 132 years. A pattern of near misses. The Sulaymaniyah incident stands alone in its fatal outcome, but it's far from the only time a meteorite has threatened human life. Throughout history, cosmic debris has crashed to Earth with startling regularity, and occasionally humans have been in the wrong place at the wrong time. In 1954, Ann Hodges of Alabama became the first person in modern history confirmed to have been struck by a meteorite. The grapefruit-sized rock punched through her roof, bounced off a radio, and hit her while she napped on her couch. She survived with a massive bruise that became one of the most famous injuries in astronomical history. In 1992, a meteorite crashed through the trunk of a parked Chevy Malibu in Peekskill, New York. The car's owner, Michelle Knapp, was inside her house at the time. The vehicle became more valuable as a piece of space history than it ever was as transportation. More recently, in 2013, a meteor exploded over Chelyabinsk, Russia, with the force of 30 Hiroshima bombs. The shock wave injured over 1,500 people, mostly from flying glass. Dashcam footage of the event went viral, showing the fireball streaking across the morning sky, a reminder that we live in a cosmic shooting gallery. But none of these incidents resulted in death. Ahmad al-Saadi's fate remains unique in verified records, making the Ottoman documents all the more significant. The science of falling stars. To understand what killed Ahmad al-Saadi, we need to understand what meteorites actually are. These aren't just rocks. They're time capsules from the formation of our solar system 4.6 billion years ago. Most meteorites begin as asteroids, rocky bodies orbiting the Sun between Mars and Jupiter. Through collisions or gravitational perturbations, fragments break free and begin new orbits. When one of these fragments intersects with Earth's orbital path, physics takes over. Traveling at speeds between 25,000 and 160,000 miles per hour. These rocks slam into Earth's atmosphere. The friction generates temperatures exceeding 3,000 degrees Fahrenheit, hot enough to vaporize most material. The rock begins to ablate, literally boiling away from the outside in. This creates the luminous trail we call a meteor or shooting star. Most meteors burn up completely, but larger ones, or those made of denser material like iron, can survive the journey. When they strike the ground, they're called meteorites. And despite their fiery descent, many meteorites are found cold or only slightly warm, their interiors protected by the ablating outer layers. The Sulaymaniyah meteorite, based on the Ottoman descriptions, likely belonged to a class called ordinary chondrites, stony meteorites that make up about 86% of all falls. These typically fragment during atmospheric entry, which explains why multiple pieces were found at the scene. Why so few deaths? Given that thousands of meteorites strike Earth every year, the question isn't why one finally killed someone, it's why deaths are so remarkably rare. The mathematics are actually in our favor. Earth's surface covers about 197 million square miles. Humans collectively occupy only a tiny fraction of this area. Most of our planet is ocean. Much of the land is uninhabited, and even in populated areas, the actual space taken up by human bodies at any given moment is minuscule. NASA estimates that about 48.5 tons of meteoritic material falls to Earth every day. Most of it arrives as dust, particles so small they drift down like snow. Larger meteorites, the kind that could cause harm, are much rarer, and the chances of one striking a person? Astronomically low. Literally. Researchers have calculated the odds of being killed by a meteorite at approximately 1 in 1.6 million over the course of a lifetime. You're more likely to die from a lightning strike, a bee sting, or in a plane crash. The fact that we have only one verified case in all of recorded history actually fits the statistical models perfectly. The Ottoman context. Understanding the significance of the Sulaymaniyah incident requires understanding its time and place. In 1888, the Ottoman Empire was in decline, but still vast, stretching from the Balkans to a Persian Gulf. Sulaymaniyah, founded in 1784, was a relatively new city, a cultural center for Kurdish arts and learning under Ottoman administration. The region was remote by the standards of the time. Communications moved at the speed of horses and caravans. Scientific knowledge, while advancing rapidly in Europe and America, spread slowly to provincial capitals like Sulaymaniyah. When the meteorite struck, local people would have had little framework for understanding what had happened. In many cultures throughout history, meteorite falls have been interpreted as divine signs or omens. The Ottoman records make no mention of such interpretations, but local oral traditions may have ascribed religious significance to the event. The fact that official reports focused on the practical details, casualties, property damage, reflects the Ottoman administration's increasingly secular, modernizing approach. The discovery of these records also highlights how much of human history remains buried in archives. Millions of documents from the Ottoman period sit untranslated and undigitized in collections across Turkey and the former Ottoman territories. Each document is a potential window into forgotten events, and the Sulaymaniyah incident reminds us how much we still have to learn about our own past. Modern implications. The verification of the 1888 death raises important questions for modern planetary defense efforts. Organizations like NASA's Center for Near-Earth Object Studies track larger asteroids that could threaten our planet, but small meteorites like the one that struck Sulaymaniyah fall below their detection threshold. These smaller impacts, while unlikely to cause mass casualties, represent a persistent, if tiny, threat to individual safety. As the global population grows and spreads, the absolute number of people potentially in harm's way increases, even if the per-person risk remains constant. The Sulaymaniyah case also provides valuable data for risk assessment models. Insurance companies, civil defense planners, and space agencies can now point to a documented fatality when calculating the real-world dangers of meteorite impacts. It's no longer purely theoretical. The search for more evidence. The discovery of the Ottoman records has energized researchers to search for additional documentation of historical meteorite impacts. Archives in India, China, Persia, and other regions with long written traditions may contain similar reports waiting to be uncovered. Ancient texts are being re-examined with fresh eyes. Descriptions once dismissed as mythological or exaggerated might actually be accurate accounts of meteorite falls. The line between legend and history is proving fuzzier than we thought. In Sulaymaniyah itself, researchers hope to locate the impact site, though urban development over the past 136 years makes this challenging. If fragments of the meteorite could be recovered and analyzed, they would provide a direct physical link to this remarkable historical event. A victim remembered Ahmad al-Saadi died without knowing what killed him. In his final moment, he likely saw only a flash of light, felt only a split second of impact. He couldn't have known that his death was unique in human history, or that more than a century later, researchers would pore over Ottoman documents to confirm his story. We know little else about him. The records give us his name, his city, and the manner of his death. They don't tell us if he had a family, what he did for a living, or what dreams he harbored. Like billions of others, he lived and died in relative obscurity. But the rock that killed him came from the asteroid belt, a region of space where the building blocks of planets orbit the sun. That rock was older than Earth itself, older than the moon, older than life. It traveled for possibly millions of years before its orbit intersected with our planets. And of all the places it could have fallen, all the empty ocean, all the barren desert, all the uninhabited wilderness, it found Ahmad al-Saadi's courtyard in Sulaymaniyah on an August morning in 1888. Conclusion written in stone and paper. The 1888 Sulaymaniyah meteorite stands at the intersection of cosmic chance and human record-keeping. Without the Ottoman Empire's bureaucratic diligence, this event would have faded into legend, another unverifiable story of death from the sky. The discovery of these documents transforms it into scientific fact, confirming what astronomers have long suspected, that somewhere, sometime, someone must have died this way. The story reminds us that we live on a planet in motion, orbiting through a solar system filled with debris. It reminds us that history is still being written as we uncover lost documents and connect forgotten dots. And it reminds us that sometimes the most extraordinary events leave the faintest traces, waiting for someone to find them and bring them back into the light. Ahmad al-Saadi's death was a tragedy, one made more poignant by its uniqueness. But the discovery of the Ottoman records has given him a form of immortality, ensuring that his name will be remembered as long as people study the intersection of human history and cosmic events. He died when fire fell from heaven, struck down by a messenger from the ancient past of our solar system. And now, thanks to paper records surviving in a Turkish archive, his story can finally be told.